Hello students, welcome to RH Chemistry. Today I am going to discuss about oxidation in organic chemistry. In one shot, we will discuss all type of oxidation of all type of organic chemistry in this. So first one we will start with, remember, oxidation of alkyl benzenes. So in the preparation of carboxylic acid, you know that we have used this particular, the oxidation of alkyl benzene. So in this case, one thing you remember, any compounds like this, CH3, or you can consider ethyl benzene, C2H5, or you can consider propyl benzene, CS3, any of such case, remember, or you can consider any long chain like this. So all these can oxidize to carboxylic acid, that is COOH, in presence of oxidizing agent, that is acidic KMNO4. So very important, all type of this, the alkyl benzene convert, any whatever the long chain attached to benzene converted into the carboxylic acid, benzoic acid. Not only like this, remember, if it is the orthoxylene, so like this, orthoxylene, if it is there, this can be converted into, so 2 COOH groups you are going to get. So this is called as phthalic acid. Similarly, remember, this is orthoxylene. So similarly, if it is metaxylene or if it is the paraxylene, then also it is converted into the dicarboxylic acids like this with the help of the same acidic KMNO4. Very important oxidizing agent. So then, one very important point which I am going to discuss is that if the compound is like this, CH3, if I use a dilute HNO3 as an oxidizing agent, remember one thing, dilute HNO3 will convert only one alkyl group out of two, only one alkyl group. Hence you are going to get the compound as CS3COOH. So if you want to convert both, you have to go for alkyl acidic KMNO4. If you want only one alkyl group to convert into carboxylic acid, then you have to go for dilute HNO3. This is the second important reagent in this case. So similarly, if I want partial oxidation if I want, partial oxidation means what? Remember, if it is, we have methyl benzene. If I have methyl benzene, I want this to convert to benzaldehyde, CHO. So in this case, remember, we can use the reducing agent, oxidizing agent, that is CrO3 in acetic anhydride. Remember, chromium trioxide is acetic anhydride, converts CS3 to CHO, and this acetic anhydride we will use only to prevent further oxidation. So prevent further oxidation, remember, hence we are used this particular acetic anhydride with CrO3. And if you remember this particular reaction we have discussed in aldehyde ketones and carboxylic acid chapter, this conversion take place is also with the help of, remember, we can call it as Itard's reaction. I think you remember aldehyde chapter, preparation of aldehyde, right? Itard's reaction, which is the oxidizing agent. Yes, CrO2Cl2, chromium, this is chromyl chloride, chromyl chloride in CCl4 or CS2 is the oxidizing agent in case of the Itard's reaction. CS3 converted into CHO. Very important. But remember, in case of the Itard's reaction, one point I am going to tell you, in case of the Itard's reaction, if I consider the compound like this, CH2CH3, if you have, see here, CS2, CS3, C2H5, CS3, anything converted into COH. But here remember, it will convert only the last carbon into CHO. So Itard's reaction, so I will write it here like this. Itard's reaction, if I consider for this, you are going to get the compound as CH2 CHO, which means remember, only last CH3 converted into CHO. You will never get the complete CS2 CS3 converted into CHO. Remember, very important, here we have discussed about KMNO4, HNO3, Itard's reaction and CrO3. Let us move to the next important reagent. So, in this particular case, I am going to discuss about oxidation of alcohols. Remember, very important concept. Remember, oxidation of alcohols. In maximum questions on this alcohols aldehydes conversion, the reagent is very much helpful. So here I will tell you first generally, then I will give you the example. Just imagine I have primary alcohol. Primary alcohol. This conversion will be like in such a way that primary alcohol first converted into, remember, aldehyde. Then this converted into carboxylic acid. Right? First I will tell you, direct conversion if you want. That is, strong oxidizing agent we are going to use. Strong oxidizing agent means which one? So K2Cr2O7, or you can go for KMNO4, or you can go for HNO3. Very, very important, remember, without aldehyde. So if aldehyde forms also, immediately convert into carboxylic acid. Primary alcohol directly converted into carboxylic acid. We need, these are the strong oxidizing agents. Then if you want reaction to stop at aldehyde stage, we required, remember, PCC, pyridinium chlorochromate, or PDC, and I will tell you another also, CrO3 in acetic anhydride. So, and another reagent is there. The name of that is Collins reagent. Remember, Collins reagent. And another reagent is there. That is Jones reagent. Remember this very, very important point. So, you can see the conversion of this PCC into the primary alcohol to aldehyde with the help of PCC, PDC, CrO3, Collins reagent, Jones reagent. What is the difference? I will tell you. Pyridinium dichromate, pyridinium chlorochromate. Collins reagent and PCC difference is, I will tell you, PCC is nothing but 1 mole each of, remember, CrO3 you have to take, HCl you have to take, and pyridine you have to take. Very important, PCC means 1 mole each of all this. The same thing if I go for Collins reagent, this is, remember, 1 mole of CrO3, 1 mole of CrO3 plus 2 mole of pyridine, very, very important, 2 mole of pyridine. Remember, that is in CH2Cl2. So, dichloromethane. So, CH2Cl2. Collins reagent and PCC difference. And what is Jones reagent? Jones reagent is nothing but, remember, chromic acid H2CrO4 in acetone CH3COCH3, aqueous acetone also you can call it as. This is Jones reagent, Collins reagent, PCC, PDC or CrO3 in acetic anhydride. Primary alcohol get converted into aldehyde. So, one example I will give you. One example, that is, for example, if you have CH3CH2OH. First oxidation by using all this reagent give rise to CH3CHO. Then oxidation, further strong oxidizing agent if you have, so that you are going to get CH3COOH. So this is about the primary alcohol story. Now we will see the story of secondary alcohol. Secondary alcohol converted into first ketone, then get converted into acid. And very important point to be remembered in this case is, whatever the number of carbon atom present in the alcohol, aldehyde with the same carbon atom, same number of carbon atom, and carboxylic acid is also with the same number of carbon atom. Same number of carbon atom. That is very important to remember. But here I will tell you, ketone with the same number of carbon atom, no doubt. So same number of carbon atom. But acid you are going to get that is with lesser carbon atom. Lesser number of carbon atom. Very important. And this conversion take place all these same as above. So I will write only one thing. Reagents same as above. So ಸ್ವಲ್ಪ ನಾನು ಕೆಲಸ ಕಡಿಮೆ ಮಾಡ್ಕೋತೀನಿ ಅಷ್ಟೇ. Reagents same as above. So no problem in it. Now we will write the example for this. See, if I give you example, if it is CH3 COH CH3. So this first oxidation with in presence of PCC, PDC, all these reagent give rise to, remember, ketone of the same carbon atom CH3 C double bond O CH3. Then very important, further oxidation by using stronger oxidizing agent. Direct conversion is also possible. So that is give rise to, remember, here the conversion will be like this. The breaking of bond will be like this. So you are going to get CH3COOH plus CO2 plus H2O. Now you can ask me, sir, from where this CO2 and H2O came? Remember, actually this converted into CH3COH. This converted into HCOOH. One thing you have to remember in this part, HCOOH, further oxidation in presence of KMNO4 give rise to CO2 plus H2O. Hence, whenever there is a KMNO4 or K2Cr2O7 or HNO3 is used as oxidizing agent, you will never end up with the product called formic acid. Always remember, formic acid converted into carbon dioxide and water. Very, very important point. You will never write formic acid in that case. So, I think you have understood. So, secondary alcohol converted into, in this particular case, like this. Yes. Now, what we will do? We will see tertiary alcohol. Very important. Now, tertiary alcohol, if I consider, remember, tertiary alcohol first converted into, first of all, here very important point is difficult to oxidize. Difficult to oxidize. So, with normal mild oxidizing agents like PCC, PDC, these things, remember, if I consider, it is very, very difficult to oxidize. Then what we'll do? But reaction is possible. Reaction is possible with, remember, potassium dichromate you can consider, or acidic KMNO4 you can consider, acidic KMNO4, or you can go for concentrated HNO3. You are going to get the compound ketone first, remember, ketone. Then it will get converted into acid. But important point to be remembered is ketone with less number of carbon atom descending in series. Acid is also having less number of carbon atom. Now we will see one example. So tertiary we will consider. So tertiary butyl alcohol, when undergo oxidation in presence of all these reagent, first minus CO2 minus H2O. Why I have written CO2 and H2O? Remember here, first this will undergo cleavage to form HCOOH. HCOOH forming CO2 H2O. Remaining is, remember, CH3 C double bond O CH3. So this CH3 C double bond O CH3. Then further oxidation you are going to get. So see here, CH3COOH, once again CH3COOH or CH3COOH, this bond undergo cleavage forming HCOOH, but immediately that HCOOH get converted into CO2 plus H2O. So this is about tertiary alcohol. Now tell me, if the reactant is like this. Now tell me, if the reactant is taken like this, CHOH, CH2, CH3. When it undergo oxidation in presence of KMNO4, strong oxidizing agent only we will consider. So what will be the product? See, if you don't use strong also, you are going to get first the compound is CH3, C double bond O, CH2, CH3. But this will further undergo oxidation to form. See, ಇಲ್ಲಿ confuse ಆಗುವಂತ part, very important to understand is, remember, here the product formed is, we can write CH3COOH plus CH3COOH. So how? I will break that bond here. I will break this bond here so that you are going to get CH3COOH, CH3COOH. Or you can get this product also. Which product? HCOOH. Further it is CO2 and H2O plus CH3, CH2, COOH. How you obtained? So if you break the bond here, HCOOH, CH3, CH2, COOH. But very important, remember, this product you will never get and this product is possible. Then the question is, how we can identify this product is formed? Why not this product? So, for that, remember, one rule I will tell you, that is Popop's rule antheli. So, very important, Popop's rule we have to remember. So, what is this Popop's rule? So, Popop's rule indicates that, remember, during oxidation of ketone, alkyl part, very important, see this very carefully, alkyl part having less number of carbon atoms, note down this point, remains attached to, remember, carbonyl carbon. Very important in aldehyde ketones chapter. So Popop's rule indicates that during the oxidation of ketone, alkyl part having lesser number. See here, alkyl part is this one and this one, which is having lesser number, this number. So with the carbonyl carbon, this alkyl part will be there. Because alkyl part having less number of carbon atoms remains attached to the carbonyl carbon. Very important Popop's rule. According to this should be the product. Right? So this is about oxidation of the alcohol, primary, secondary and tertiary. So if you are not understood, go through the video once again. Definitely you will understand. Definitely you are going to get the use of this in the upcoming competitive exams. So next, the one which I am going to discuss is another important, that is MnO2. MnO2 is also oxidizing agent. About this we will discuss. So remember, first of all, this is mild oxidizing agent. Then what it will do, because of this mild oxidizing agent, it will only selectively oxidizes, remember, allylic and benzylic primary and secondary alcohols to aldehydes or ketones. And remember, double bond or triple bond, no effect on double bond or triple bond. So it's a mild oxidizing agent. Only allylic or you can say benzylic can be converted. One example I will give you. If the reactant is like this, CH3, CH2, CH, double bond, CH, CH2, OH. So this will be converted into. Remember, in this particular case, which one is the allylic one? Allylic one is this one, remember. Allylic one is this one. Hence you are going to get the product as CH3, CH2, CH, double bond CH without affecting that, then CHO you are going to obtain. If it is like this, PH, CH2, OH. Now it is benzylic, correct? You are going to get the oxidation because of MnO2, you are going to get PHCHO. Right, you have understood? Right. So pH, if it is like this, pH, C, OH, then write this, the ring. So now here you can see which one is the benzylic. This one is benzylic, correct? It will not oxidize this OH. Remember, only this will oxidize to ketone. So you are going to get pH, C double bond O. So this remains the same. This remains the same. So like this, remember. So if it is like this, if the compound is like this, OH and double bond is here. Now which is the product formed? So no product, remember. No product. Because here it is not allylic OH. There is no pH, that is a benzylic OH. Hence this reaction never take place in this particular case. This is about MnO2. This is about MnO2. Then we will discuss about very important, that is SCO2, selenium dioxide. Very important, selenium dioxide. So remember, selenium dioxide, it may be acetic acid. Remember, acetic acid, or it may be in acetic anhydride. Acetic anhydride. So temperature required is around 100 to 140 degrees Celsius. It acts as a good oxidizing agent. So in organic chemistry, SCO2 plays a very important role. Remember that particular thing. So in this case, we will see. So what is the importance of this SCO2? Remember, this SCO2 will oxidize. This will oxidize only active methyl group. Very important. Active methyl group or active methylene group. Active methylene group to aldehyde or ketone. Very important. It will oxidize us active methyl group or active methylene group to aldehydes or ketone. Not only this, it can convert triple bond also to aldehydes or ketone depending upon the reagent. That also I will give the example. Fine. Now first we will see what is active methylene group. So remember, active methylene group is nothing but adjacent to double bond O. So if I write the compound like this, then active methylene group is this one or this one. Active methylene group is this or this. Now this, when SCO2 react with this, you are going to get the compound. Out of two, any one you are going to get converted into double bond O. Right? So another example I will give you. This pH, CH2, C double bond O, pH. Which one is active methylene group? This one is the active methylene group. Remember, this one is active methylene group. Hence, you are going to get the product as pH, C double bond O, C double bond O, pH. Right? Or like this, CH3CHO. CH3CHO. What's the product? Yes. So, CHO you are going to get. If this is like this, CH3, C double bond O, CH3, acetone. So here you are going to get, remember, so CHO, C double bond O, CHO. So both CH3, CH3 get converted into CHO. Then, or if it is like this, pH, CH2, pH. Then you are going to get pH, C double bond O, pH. And also oxidizes triple bond I told, right? See here, HC triple bond CH get converted into HC double bond O, C double bond O, H. Diketone. Or If it is R C triple bond C R, it will get converted into R C double bond O C double bond O R. So very important. You go through all these things, you'll understand what is the use of SCO2. Very important reagent in organic chemistry. So SCO2 will convert active methyl group or active methylene group to aldehyde or ketone. This is about SCO2, selenium dioxide. Now we will see some other reagents, right? So that is, we know that. So whatever the points I am going to tell here, these are addition points. Remember that. Now, KMNO4, if I consider, KMNO4 oxidizes. Remember, primary amines to RNO2 also. That is nitroalkane. It can convert. Then we know Tollens reagent. So what is Tollens reagent? So ammonical silver nitrate, AgNO3. So what it will do? It will convert RCHO to RCOO minus, that is carboxylate ion acid, right? This Tollens reagent. And similar, or here I will write Fehling's solution. So Fehling's reagent also you are going to get the same conversion. Remember that, very important point. Then haloform reaction. Haloform reaction is another very important concept in organic chemistry. So if possible, I will give you a separate video on this haloform reaction in the later part. So what it will do? Haloform reagent is which one? Reagent is I2 with, remember, KOH or NaOH, alkali. So, or you can say calcium hydroxide, CaOH twice. Or NaOI, sodium hypoiodide, or potassium hypoiodide, KOI. Or you can say calcium hypoiodide, CaOI twice. Any of these can be given as haloform reagent. Remember that part. Then what will this haloform reagent will do? Remember that, very important. So which will help you in the organic chemistry to the greater extent. This will convert this CH3 CHOH, or you can say CH3 C double bond O group to, only these are the group you are going to get. So to CHI3 you can say. So fine. The compound having these groups can show haloform test. One example I will give you. RC double bond O CH3 get converted into RCOO minus plus iodoform is formed CHI3. So this group or this group will give you haloform reagent. So haloform reaction. Here this is also, remember, oxidation reaction. So hence I have taken it here. Then we discuss about another, the important for mainly JEE and NEET exam, remember. So open your oxidation. So open your oxidation. Open your oxidation. What is the reagent? Remember, reagent is aluminium tertiary butoxide with, remember, acetone. That is like this. CH3. So CH3 tertiary, right? CH3 and thrice aluminium plus CH3 C double bond O CH3. The one example I will give you for this particular reaction, that example you remember. If I consider RCHOH, R dash give rise to, in presence of this, remember, you are going to get RC double bond O R dash. Conversion of the secondary alcohol to this one. Open air oxidation is the reagent which will convert always secondary alcohol, only secondary alcohol to remember ketone. Secondary alcohol to ketone conversion we are going to use open air oxidation. This is about the another oxidizing agent. Then we'll move to Bayer's test. Bayer's test. So in this particular case, what is Bayer's reagent? What is Bayer's reagent? The video may be longer because here I have taken all the reagents what is possible. So Bayer's reagent is nothing but remember cold, dilute, neutral or alkaline KMnO4. Remember, cold, dilute, neutral or alkaline KMnO4 is the Bayer's reagent. So what it will do? It will convert alkenes to 1,2 glycols. 1,2 glycols. So alkynes to here remember 1,2 diketones. So convert alkene to 1,2 glycol and so alkynes to 1,2 diketone. One example I will give you. So see, alkenes, one example, CH2 double bond CH2 in this oxidizing agent. So you are going to get ethylene glycol CHOH, CHOH. Right, very simple. Then for alkyne I will give you another example. That is, if you consider CH3 C triple bond CH. So you are going to get CH3 COOH plus CO2 plus H2O. Already I told this converted into CH3COOH, right? CH3COOH, but this converted into HCOOH, CO2 and H2 is going to form. If it is like this, CH3 C triple bond C CH3, then it will get converted into diketone like this, CH3 C double bond O C double bond O CH3 like this. But very important, but if it is alkyne, that is ethyne, CH triple bond CH, then you are going to get COOH like this. And Bayer's test is used to distinguish unsaturated compound alkene with the unsaturated hydrocarbon with saturated hydrocarbon. Very, very important. This part remember. So next we'll move to. See, here I have taken cold, dilute, neutral, right? So if it is, remember, if it is acidic KMnO4, or you can say acidic potassium dichromate K2Cr2O7, or you can say hot KMnO4. Here it is cold KMnO4, right? Here if I take hot KMnO4 reaction with alkanes or alkynes, we will see. Carefully listen this point. This is also very important for your exam. So now what happens? So first I will tell you the rules in this particular case. First understand the rules. So rules is that if it is alkenes, the rules are like this. CH2, if it is terminal alkene, always give rise to carbon dioxide. Remember, if it is terminal alkene, andre at the end if you have double bond, you are going to get CO2. If it is in between CH double bond type of group, you are going to get COOH. Very, very important, COOH. If it is RC double bond double bond C R, such a type of group, remember, you are going to get RC double bond O R. Like this. RC double bond CR, this converted into this. Now for example, we will see CH2 double bond CH2. This will get converted into 2HCOOH. Remember, CH2 HCOOH. Immediately give rise to CO2 plus H2O. Immediately give rise to CO2 plus H2O. Like this, the reaction you can see. If this is like this, CH3, CH, double bond, CH, CH3. Then it will get converted into, by using this reagent, remember, you are going to get 2 moles of acetic acid. 2 moles of acetic acid. If it is like this, CH3C double bond CH2 CH3, then you are going to get, remember, ketone CH3C double bond O CH3 plus this get converted into HCOH. HCOH means CO2 plus H2O you are going to obtain. This is about rules for alkenes. So what all the product you are going to obtain. Now I am going to discuss about with alkynes. Remember, with alkynes, if I consider with alkynes, first I will tell you the rules. With alkynes, the rules are like this. So in this particular case, if it is CH triple bond, which means what is this? Terminal CH, right? If it is terminal CH, then it will get converted into CO2 and H2O. Then if it is like this, RC triple bond, then it will get converted into RCOOH. Remember that. So for example, I will give you, for example, reaction if it is, so CH triple bond CH. What is the product obtained by using this acidic KMnO4 or hot KMnO4 or acidic potassium dichromate? The product formed is CO2 plus CH2O. CO2 plus H2O. 2 moles you are going to get, definitely. Then, if it is CH3C triple bond CH, you are going to get, see, this CH is there means CO2 H2O. This is there means you are going to get CHCOH. Hence, the product formed is CH3COOH plus CO2 plus H2O. Right? If the compound is like this, CH3C triple bond C, CH3, 2-butane, then you are going to get 2 moles of CH3COOH. Like this, you are going to get the compound. So this is about, remember, alkenes and alkynes with acidic KMnO4 or hot KMnO4. And now I came to the last part in this very important, remember, and very interesting point also. So periodic oxidation. Very important for NEET and JEE. Periodic oxidation. Periodic oxidation means which is the oxidizing agent. Remember, HiO4 with lead tetraacetate, or sodium bismuthate. Remember, HiO4. Periodic oxidation means HiO4. HiO4 is known as periodic acid. So question can be given like by giving any reagent, they can ask how many moles of periodic acid is required, like that. So for this I will give you with example different types of oxidation. First one, always this will oxidize two adjacent, very interesting, very important. So two adjacent OH group if I take. Two adjacent OH group. One example I will give you. See, if the compound is like this, RCHOH, CHOH, R dash, then the product formed is, here always remember 1 mole of HiO4 is used. Always, how to calculate mole, I will tell you the trick. Whatever the number of OH is there, minus 1. Whatever the number of OH is there, minus 1. 2 is there, hence 1 mole of HiO4 is required. You are going to get, remember, RC double bond OH plus R dash C double bond OH. So very important. One more point I will tell you. Wherever alcoholic group is there, converted into aldehyde. Alcoholic group converted into aldehyde. If it is already aldehydic or ketonic group is there, that will get converted into acid. Remember this. Alcohol is there, get converted into aldehyde. Aldehyde ketone already is there in the given reagent, converted into acid. So this is about this example, 2 adjacent OH group. So second one will take. All these are adjacent only. So single, if it is there, it will never act as oxidizing agent. 2 adjacent CHO group. Very important. 2 adjacent CHO group. And all these, you remember, I will give you the PDF file of all these, the sheets, whatever I have prepared in a Telegram group. So you have to, if you don't have Telegram in your mobile, so download that Telegram and join me in the Telegram. I have given the link in the description box. There I will give you all these PDF files. So now the compound, if it is like this, HC double bond O, C double bond O, H. So this will get converted into, here also required 1 mole of HiO4. So aldehyde is there. You have to get acid, correct? So you are going to get 2 moles of HC double bond O, OH. Correct, understood? So very important in this case, 2 adjacent group is there. Now you will see, I will give you answer for all these questions. 2 adjacent OH, sir, 1 adjacent, 1 OH and 1 CHO, if it is there, what happens? That also I will give you the answer. Now let us go to 2 adjacent C double bond O. So ketone group, if it is there, what happens? See, RC double bond O, C double bond O, R dash, Q raised to. Once again 1 mole of HiO4. Remember, 2 ketone, 2 aldehyde minus 1, 1 mole. 2 minus 1, 1 mole. So like this you have to calculate. So here you are going to get RCOOH plus R dash COOH. Aldehyde or ketone converted into acid. Correct? So 2 adjacent OH, 2 adjacent CHO, 2 adjacent CO. What will happen? We have seen. So along with this, remember, I will give you next the possibilities. Next possibilities we will see. So now, as you told, if it is, remember, fourth one, if it is fourth one, so what I will do, so everything adjacent is over, correct? Now what we will do, this one and this one will make it adjacent. If it is adjacent, C double bond O, H and in this case CHOH. See, C double bond O, H and CHOH group if it is there. So that I will take one example. HC double bond O. So in this particular case, remember, I will take the example like this. So I think it is visible for you. So HC double bond O, CHROH. See here you can see OH and C double bond O, H, that is aldehyde and alcohol is adjacent to each other. Here also you required 1 mole of HiO4. We know that ketone converted into aldehyde converted into acid, alcohol converted into aldehyde. So here you are going to get, remember, this is aldehyde, get converted into acid. So HCOOH plus RCHO. R is group here, right? So RCHO. This is this. Now what we'll do? These two adjacent will keep, correct? So adjacent. If it is adjacent aldehyde and ketone groups. If aldehyde and ketone is adjacent to each other, for example, RC double bond O, C double bond O, H. So this is aldehyde, this is ketone. Then you are going to get, in both the cases it will get converted into acid, remember. So you are going to get RCOOH plus HCOOH. Here one thing you see, HCOH further will not give rise to CO2 and H2O. This is the final product. So here also this is 1 mole of HiO4. 1 mole of HiO4. So finally another combination is left. Which one? Aldehyde alcohol we have seen. Ketone alcohol we have not seen. Yes. Adjacent ketone, yes, adjacent C double bond O and CHOH. This is the only combination left. So this will give rise to, in this particular case, you can see here I am going to write, I think this is visible, right? So I will write R C double bond O CHOH R dash, right? Now you are going to get once again 1 mole of HiO4. Remember, 1 mole of HiO4 you are going to get. So if it is, see this once again converted into acid, RCOOH plus R dash CHO you are going to obtain. So this is about the 6 types of the reactants and its products, right? Now I am going to give you another very important point in this case. If it is, remember, 7th one, adjacent CH double bond O. So in this particular case, adjacent, I will write RCHNH2 and CHOH group, alcoholic group. So alcoholic group and amine group if it is there. See, for example, RCHNH2, then CHOH R dash. So remember, this will convert into aldehyde, no doubt. So R dash CHO, I will write it first. R dash convert into R dash CHO. Now, this RCHNH2 also, remember, converted into NH3 first. This NH2 converted into NH3, you are going to get, here also remember, RCHO. R dash CHO, NH3 and RCHO if it is adjacent RCHNH2 and CHOH aldehyde group. Now I will give you, if the question is asked, what type of question can be asked? See, what type of question can be asked on this concept? So they can ask, how many moles of HiO4 needed to oxidize? Just imagine how many moles of HiO4 needed to oxidize they are asking. The compound given is RCHOH, CHOH, CHOH, R dash. How many moles of this, the HiO4 is needed? What I told, whatever HiO4 it will be there, the moles depending on how many OH group is there, how many CHO group is there, or how many COO group is there, right? So hence, here you can see there are 3 OH group. Hence remember -1. So 2 moles of HiO4 is needed. Then what is the product formed? See, product formed. This is the alcoholic group. This is also alcoholic group. Hence remember, I will write it very easily. RCHO plus R dash CHO. RCHO, R dash CHO. Then what about this group? What about this group? Remember, so this get converted into HCOOH because it is in between, it is there, right? So it is secondary alcohol, in between it is there, hence it will get converted into HCOOH. Very important, RCHO, R dash CHO, HCOOH. Once the question asked on glucose, so C6H12O6, how many moles of HiO4 needed? See, I will write it like this. CH2OH. So, I will not write exactly glucose. I will write C6H12O6 structure. Any isomer of this particular structure, you will get the same product. Remember that very important point here. Now, this is the group. How many HiO4 needed? How many moles of HiO4 needed? See, how to calculate? I told HOH or C double bond O or CH2OH, or you can say CHO or NH2, whatever the number of group is there, you calculate. 1, 2, 3, 4, 5, 6, -1 has ones 5 moles of HiO4 is needed. See, 1, 2, 3, minus 1, 2 moles. 1, 2, 3, 4, 5, 6, minus 1, 5 moles of HiO4. So, 5 moles of HiO4 is needed. What is the product formed? Very important, that one. See, this is CH2OH, correct? This will get converted into, the product is HCHO. See, understand? CH2OH is there, alcoholic group is there, converted into aldehyde, so HCHO. Then in between alcohol, whatever it is there, converted into COOH, I have seen. So in between, if it is there, converted into HCOOH, and CHO also get converted into HCOOH, hence remaining all get converted into 5HCOOH. To understand this, what I will do, I will number 1, 2, 3, 4, 5, 6 carbon. Here it is present 6 carbon. Right? 6 carbon. Here carbon is 1, 2, 5. You can understand now. 1, 2, 5. Right? So fine. So the last question I will give you. If it is fructose structure, see, CH2OH, then remember C double bond O, then like this, CH2OH, right? HOH, 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 CH2OH, CH2OH. So this is the structure of fructose. Now we will see how many moles of HiO4 needed. Remember, number of moles does not change because these two are isomers. Hence here also we needed 5 moles because 1, 2, 3, 4, 5, 6 minus 1. 5 moles of HiO4. So now you see what is the product formed. Very, very important, that part. What is the product formed? What I will do, I will number this once again. 1, 2, 3, 4, 5, 6. See, 6. Now see the product. Now once again, there is no doubt in this case both are aldehyde. Correct? Both are aldehyde get converted into what? So HCOOH. Sorry, this also formed, but I will write it here. So HCHO. Which one? This is also aldehyde, CHO. Same, this is also aldehyde, this is also aldehyde. Converted into HCHO. Which means the number of carbon numbers present in HCHO, which will form is, remember, 2 moles, 1 and 6 carbon. Carbon number, 1 and 6 give rise to HCHO. Then remaining, remember, 3, 4, 5. 3, 4, 5. You are going to get this. So 3 moles of this, 3rd carbon, 4th carbon and 5th carbon HCOOH. Then I have left with second carbon ಏನು ಬರ್ತದೆ ಹಾಗಾದ್ರೆ carbon dioxide ಬರ್ತದೆ ಗೊತ್ತಿರಲಿ C double bond in between if it is there carbon dioxide CHOH in between it is there HCOOH. Very, very important. How many moles required for this? 5 moles. First and the last terminal converted into HCHO. In between 3, 4, 5 converted into HCOH. And the second one give rise to CO2. So this completes oxidation process in the organic chemistry. For my knowledge, remember, I have considered all the possible oxidizing agent. Other than this also, if it is there, please you have to refer some other books. So if you like the video, share to your friends. So subscribe to my channel if you are not subscribed. Thank you. Have a nice day.